Good morning, everyone. I'm just going to head right into it so that this video is as short as possible. This is your assignment for the next 2 days, Tuesday, Wednesday, May 19th and May 20th. This 5.2.2 day 2 packet. Again, you have 2 days to complete it. Basically, numbers 1 and 2 are the same as the notes from Thursday and yesterday. And then pretty much the new stuff that you guys tried to do on your own yesterday, which is doing the inverses of logs and exponentials. One thing that I want to mention before doing some inverse examples for you guys is anytime you see a log without a base, remember there's always a subscript. There's always 3 parts to a log, 3 parts to an exponential. Always it has a subscript. It has a value next to it that it's taking the log of, and it's always equal to something. But anytime that you have a log without a base, let's see, you have 2 examples in your packet. This letter, like there's no base, and this one, there's no base. So anytime you don't see a base, it's always understood to be 10. I'm gonna write that down right here. It's always understood to be 10. You can write it if you want to, but it's not necessary. So again, anytime you don't see a base, it's understood to be 10. Okay, so we're gonna do 4 examples together. You don't have to write these down. You can just refer to them when you do your own work. Pause, fast forward, rewind as much as you need. Like if you don't need 3 and 4 and you already get it, just stop the video and go do your work. So find the inverse of each function. Be sure to write the inverse function with proper notation. Inverse is still the same 2 steps. You're gonna, or I mean, it could be 3 steps depending on how many you count, but first step is switch the x and the y. Second step, solve for y, and then of course you can count the third step as putting it back into function notation, inverse function notation. So that's what we're gonna do for number 1. I'm just automatically gonna switch the x and the y. So x equals log base 1/5 of y minus 4. So I gave you some harder examples for these. That way you can kind of see the more difficult ones. So the first thing that you should do is you should always get, like we're trying to solve for y. So that means we also have to get the log alone because the 1/2 subscript in the y belongs to the log, but the -4 does not. So this -4 just needs to move to the other side first. The log needs to be alone. I'm going to add 4 to both sides. Now I need to try to get y alone, but it's attached to the log. The only way to undo a log is to popcorn it and put it into an exponential. Like logs can only be undone with exponentials, and exponentials can only be undone with logs. That's the only way to get rid of it. So I'm going to popcorn. So 1/5 to the x plus 4 equals y. Remember, the number on the other side of the equal sign is always the exponent, and this is always the base of the exponent, exponential. So 1/5 to the x plus 4 equals y. Once y is alone on one side of the equal sign, you've already solved for it. You're done, okay? So my inverse function notation is f to the -1 of x equals 1/5 to the x plus 4. So this is the inverse of that, and you can kind of see similar values. I see the 1/5, I see the opposite of subtracting 4, and it's adding 4, and it's in the exponent here, okay? Let's try an example with an exponential. I switch the x and the y. I see that my y is in the exponent here in the numerator of the fraction. So same thing here. I'm going to get my exponential alone. I'm going to solve for y. So I'm subtracting 1 from both sides. 5 to the y over 2, okay? Now the only way to undo an exponential is to put it back into a log. I'm gonna reverse popcorn. So I'm gonna write my log. The base of the exponential is always the subscript, the base of the log. The exponent is always on the other side. And the thing that you're taking the log of is always on the other side of the equal sign for the exponential. So I'm going to put my parentheses around here to show that the x minus 1 is inside the log, okay? Is y alone? No, because it's being divided by 2. So what's the opposite of dividing by 2? Multiplying by 2. So my inverse function notation is g to the -1 of x is 2 times the log base 5 of x minus 1. Done. Okay, so if you're pretty comfortable with this, you can move on to your number 3 on your packet, but I'm going to do 2 more examples. So again, switch x and y of 2 to the x minus 7. My log is not alone. Remember, 2 to the x minus 7 is inside the log. You can't just move the stuff over, okay? You can't just move the 2 over. It's a subscript. The 6 doesn't belong to the log. It's just saying that the log is being multiplied by 6. So the opposite of multiplying by 6 is dividing by 6. Get the log, get the exponential alone before popcorning or reverse popcorning it. Okay, so now that my logarithm is alone, the only way to undo a logarithm is change it into an exponential. So I'm going to popcorn. 2 to the x over 6 equals, and I forgot to change this to y. Two to the x over 6 equals 2 to the y minus 7. Okay, so I'm trying to still solve for this y. Okay, I have another exponential. I'm going to add 7 to the other side again. What's the only way to undo an exponential? Put it back into a log. So don't get confused. Anytime you see an exponential, anytime you see a variable and an exponent, you need to undo it with a log. So this is a bit of a harder one. The base of the exponential is always the subscript of the log. The exponent always goes to the other side. What it's equal to on the other side always goes inside the log. So basically, I had to reverse it twice. So I started with a log, I changed it to an exponential, and I put it back into a log. And the only purpose of that is because there was that extra exponential on the inside, the 2 to the x. So log base 2 of 2 to the x over 6 is your inverse. I'm going to do my inverse function notation. All set. Last one, okay? Switch x and y. Again, my log is not alone, so I'm going to add 7 to both sides. Remember, you should always get rid of addition and subtraction before multiplication division. It's a reverse PEMDAS when you're undoing. Add 7 to both sides. I'm going to divide both sides by 3 to get rid of the multiplying by 3. Okay, the only way, now that the log is alone, the only way to undo it is using an exponential. I'm going to popcorn. So 5 to the x plus 7 over 3 equals negative 4y. This is always the exponent of your exponential, what it's equal to on the other side. This is always the base of the exponential. Base equals base. 5 to the x plus 7 over 3 equals negative 4y. That's always how you popcorn it, how you undo it. Okay, is y alone? Nope. Divide both sides by negative 4 and you're all set. This is an exponent, you know, for the 5. Inverse function notation is j to the negative 1 of x. 5 to the x plus 7 over 3 divided by negative 4. Okay? That's pretty much it for these. So I know that these two are a bit complicated, but stuff like this too will be in your packet. Okay? If you have any questions, please post to Google Classroom. You're doing this for number 3, not 1 or 2, just number 3. Again, you have 2 days. Let me know if you have any questions.